And welcome to today's lesson. In this first tutorial, we will be able to identify the least common denominator, or LCD, and we will add and subtract rational expressions. We are in section 8.5 in our textbook, and we're talking about adding and subtracting fractions this time. Whenever we want to add or subtract fractions, we must have a common denominator. The least common denominator, or the LCD, is what we'll call it for short, is the product of all of the prime factors. Basically, what we're going to do is look at all of the factors in the denominators and make sure that all of the factors are in each of the fractions that we want to add or subtract. Let's start off with a basic problem with just numbers, no variables. We want to take 2/3 and add 3/5 to it. Obviously, these numbers in the denominator are not the same, so therefore we cannot add these two fractions yet. We need to find the LCD. What we need to do is figure out what number 3 and 5 both go into so that we can write that as a common denominator. The product of all the prime factors would be 3 times 5 in this case, or rather 15. So we know that each one of these fractions wants to have a denominator of 15. Now, how are we going to make that happen? Well, 3 needs to be multiplied by 5 to get 15. So if I take the 3 and multiply by 5, then I get my 15. But if I do that, then I've changed the number 2/3. So I have to also multiply the numerator by the same number. If I multiply the numerator and the denominator by 5 each, then I haven't changed the 2/3. All I've done is multiplied by 1. So the numerator would be 10 and the denominator would be 15. Same sort of thing over here. The 5 needs to turn into a 15, and we're going to multiply by 3 to be able to do that. Now, of course, we have to multiply the numerator and the denominator by 3, so that changes the numerator to become 9 and the denominator to be 15. Now that we have the same denominators, we can add these two fractions together simply by taking the numerators and adding them to get 19. And there's our answer. In Algebra 2, we're going to involve some variables, but it's going to be the same exact process. If we want to add these two fractions together, we have to understand first that we can't do it without the same denominators, and these clearly are not the same denominators. So we need these two fractions to have the same denominators. And in this case, the prime factors would be x and y. So when I multiply them together, I simply get xy. So each of these two fractions wants to have a denominator of xy. X is going to turn into xy by multiplying by a y, so I have to do that to the numerator and the denominator. The numerator turns into 1y, or simply y. This y needs to turn into an xy, so I need to multiply by an x. I have to do that to the numerator and the denominator, so the numerator becomes 3x. Now that these two fractions have the same denominator, I am able to add them together, and that denominator is just going to be xy, and I get the numerator by taking these two numerators and adding them together. I'm going to go in alphabetical order, 3x plus 1y. They're not like terms, so I'm not able to add them. They have to just be written side by side. So that's the basic premise of what we're doing today. Let's look at a few more problems and add, subtract these fractions. Example number 1 is pretty simple, ready to go. In fact, the two denominators are exactly the same, so I'm able to add these two fractions together. The denominator, of course, does not change. I get 3x, and in the numerator, I get 4 plus 5, which would make 9. So I've added the two fractions together. There's one more step in this problem, though, because now that I have this fraction, I see a factor that I can cancel away. 9 and 3 will reduce. The factor of 3 will cancel away with one of the factors of 3 up top, leaving 3. So I'm going to have a 3 in the numerator and an x in the denominator, and that's the simplified version. The second one, I'm subtracting. You have to watch out for subtractions, especially when you're going to be subtracting multiple terms. I see two terms. This is a binomial in this numerator. I'm going to be subtracting both parts. First of all, I know that I can do this subtraction because I have the same denominators. So let's go ahead and do that. The denominator is not going to change. It's going to be an x plus 3. What I'm going to do is I'm going to subtract both parts of this. That's really like a distribution. I'm subtracting the x and I'm subtracting the negative 2. So I have 2x from the first numerator. I'm subtracting x and I'm subtracting negative 2, which makes a positive 2. Watch out for that. Let's get our like terms together. I have a 2x minus 1x. That just makes 1x. So we have x plus 2 divided by x plus 3. Finally, our example 3, this is the first problem that we actually don't have, on this page at least, that we don't have the same denominators. So there's no way to do this subtraction yet. We need the denominators to be identical. And this time we have a lot. We've got some numbers and we've got some different variables. So we have to figure out what needs to happen to make these denominators the same. We need to find the LCD. Let's first talk about the numbers. I've got 5 and I've got 10. I need to figure out what's the smallest number that both of these numbers go into. Hopefully you're saying that it's 10. 10 goes into itself clearly, and 5 also goes into 10. You do not need to say 50. You don't just always multiply the numbers. You take the smallest number that both of these numbers go into. So in this case, it is 10. Both denominators need to have a 10. Let's see what other factors we have, and I'm going to go in alphabetical order. I see an A, so that means both denominators are going to have an A. I see a B, that means that both denominators are going to have a B. I see a C squared, that means that both denominators need to have a C squared. I don't believe I have anything other than that. There we go. 10ab squared will be our common denominator. So now what we need to do is make these denominators turn into that. Well, the 10 is already a 10, and we already have the b, but we're missing the a and the c squared. So I'm just going to multiply by a and c squared. I have to do that to the numerator and the denominator, of course. Let's see what the new numerator will be. 9 times ac squared is just 9ac squared. Okay. Let's change this denominator. Now we only had 5, and it needs to be a 10, so that means I need to multiply by 2. We already have the a, and we already have the c squared, but we're missing the b. So that means I need to also multiply by a b. The 2 will make the 5 turn into a 10, and the b is needed as well. So I multiply top and bottom, numerator and denominator, by 2b. The numerator now is going to be 4 times 2 is 8, and b times b is b squared. Now that I have the same denominators, I can combine these two fractions together. The denominator will remain the same, and the numerator is going to be 9ac squared minus 8b squared. And since those are not like terms, I will just simply write them side by side, and I will be finished. Just a quick review from our previous tutorial. Understand that nothing can cancel away. I don't have any factors that are common in the numerator and the denominator. Thanks for watching this quick intro, and I'll see you in the next tutorial, and we'll do some more complicated problems.